Hello, students. So we left off uh, where we were trying to find the enthalpy of reaction for the magnesium hydroxide converted to magnesium oxide reaction. And we want to find out the enthalpy of this reaction. So what we can do is use the reactions from your other lab mates. So, for example, reaction 3 from pot number 3 was the magnesium chloride plus sodium hydroxide going to magnesium hydroxide in solution. No, sorry, the solid plus sodium chloride in solution. This is aqueous, meaning that it's in solution. And you calculated from your equations the enthalpy of this reaction. And then for the fourth reaction, pot number 4, the salt magnesium chloride to magnesium chloride solution. And this is enthalpy for the reaction number 4. Pot number 2, use magnesium oxide and hydrochloric acid to form magnesium chloride and water. This is magnesium chloride in aqueous solution. And we had a given equation. So I will just call it given, G for given, and it's water evaporation. Let's call it H. And this one was H2. So we need to find out on this set of reactions, where do we have the reagents and where do we have our products. So we can see that in reaction number 2, here we have the reagent. We have it in reaction number 3 as a product. And the magnesium oxide, which is a product in our reaction of interest, is reagents in the reaction number 2. So the first step that you need to do is to flip these two equations so that the product is in the product position, reactants are as reactants, as in the equation that we are interested in. And what I'll do is just rewrite equation 3. So equation 3 for the negative, let's call it the negative, the reaction 3. It's magnesium hydroxide, it's a solid, plus sodium chloride, aqueous, going to producing magnesium chloride, solid, plus sodium hydroxide, aqueous. And just checking that we are using the correct equation. Yeah. So this means that the enthalpy of this reaction is a negative from the one obtained experimentally from pod number 3. Then we do the same for second reaction. So magnesium chloride in aqueous solution plus water equals magnesium oxide plus hydrochloric acid. And again, we flip the sign of the enthalpy for that reaction. And what we can do now is start checking for what we can cancel out. So considering reaction 4, we can see that magnesium chloride cancels out with the magnesium chloride in reaction 3, like so. We can also cancel out aqueous magnesium chloride from reaction. Oh, I'm sorry. You can only deal with this reaction, with this reaction, with this reaction, with this reaction, and I missed the pod number 5 reaction. So the 5th reaction, did I write it here? Oh, I missed it, sorry for that. So pod number 5, use magnesium chloride, aqueous. Oh, no, sorry. They didn't use it. They used sodium hydroxide plus hydrochloric acid and reduced sodium chloride in aqueous solution plus water. Now we can cancel more stuff. So let's see. Here we have 2 molecules of hydrochloric acid. We can cancel out with the negative of the reaction number 2. Oh, sorry. And to clarify, we have a 5th enthalpy of reaction. We can also cancel out sodium chloride with sodium chloride, the 3rd reaction. Here we have this is a liquid. So we can cancel out these 2 water molecules from the 5th reaction with the 1 water molecule in the 2nd and 1 water molecule in the given reaction. And here we have 2 sodium hydroxides, the 5th, which cancel out with sodium hydroxides in the 3rd reaction. And just to clarify, this should be aqueous also. What else can we cancel here? So we have magnesium chloride here, which cancel out with magnesium chloride in aqueous right here. And we are missing, what are we missing? I think we are done. So we have magnesium hydroxide, magnesium oxide, and water. Remember that this one was already flipped, so we don't use this equation anymore. We use the inverted version. So considering this equation, this equation, this equation, this equation, and this equation, we can see that we are left only with magnesium hydroxide as a reagent and water and magnesium oxide as products, which is what we began with here. So it's just a matter of you adding up all the enthalpies of the reactions that correspond to the equivalent reaction that we are interested in. So we can go from top to bottom. So this is equal to the enthalpy of reaction number 4 plus the enthalpy of the given reaction for evaporization minus the enthalpy of the third reaction, this one right here, minus the enthalpy of the second reaction plus the enthalpy of the fifth reaction. And you can use the experimental values both for the beaker and for the styrofoam calorimeter and see how close they are from one another. You do the same analysis for route number 1. So this is the procedure for route 2. And if you have any questions, you can go to office hours or you can send me a message in Canvas.